Welcome to the calculus edition of Math Magic with Jen. And today we're going to be going over refreshing some algebra skills, so calc prep. So yes, calculus uses a lot of skills that we expect you to remember at the drop of a hat. So today we're going to practice some factoring of polynomials, and then in another video we're going to have some more advanced factoring. Okay. So, of course, where do you see it? So in Calc 1, so if we're talking about a typical semester Calc 1 course, evaluating limits is usually where you start. And yes, when you're doing those, we do use algebra and factoring. Once you start learning the fundamental concept of Calc 1, which is derivatives, you'll want to be able to factor to simplify your answers. And then we do an application of derivatives involving maxes and min or extrema, and that also uses factoring. So it happens, okay? So we expect you to know what to do. So as you can see here, it says the faster you are at recognizing that you, one, need to factor, because that's the first thing is how do you know if you need to? And two, how do you do it? Like, which type of factoring are you doing? So today we're going to tackle identifying the type of factoring that you need. When you need to do it in the middle of a calculus problem, we'll be covering as we do calculus topics, right? So right now we're just prepping the skill, but as we are, evaluating limits, I will show you when you go, oh yeah, I need a factor. Okay, and this is what I have to do. All right, so let's go for it. So the first thing you want to ask yourself, assuming you know you need to factor, so that's the first assumption, right? I need a factor. How many terms are in the polynomial? Now that might seem weird, but when you can figure out how many pieces you have, you can know what paths are available to you. So when you have two terms, you basically have a bunch of formulas or greatest common factor. Okay. So I'm actually going to skip down to the end here where it says greatest common factor. So I typically just refer to it, and a lot of people refer to it as GCF. So when you hear me say GCF, that means greatest common factor. So that means that you can take something out of every term and pull it out, factor it out. Okay. Otherwise, if you're using special formulas, if you have two terms, if the two terms are perfect squares, and they're glued together with subtraction, then they can be factored with this formula. Okay, so a squared minus b squared equals a minus b, a plus b. Okay. Now, for those of you who are thinking, well, Jen, can it be a plus b, a minus b? Yeah, it can. Okay. All right. The harder one, it's not typical. It's not that it's hard, just sometimes students can't remember the difference of cubes and sum of cubes formula. So first off, you have perfect cubes, okay? And it's either glued together with subtraction or addition. Okay. Now, I myself used to have trouble remembering this formula too until a friend taught me a cute little trick. So of course, I'm gonna teach you a cute little trick. And maybe you already know it, but it helps me. All right, so I want you to notice that both of these formulas have a squared, AB, B squared. So A squared, AB, B squared. Okay. But the signs in between are different. And so the cute little trick that was taught to me was SOAP. So the S stands for same. The O stands for opposite. And AP stands for always positive. Okay. So how this works is that the first sign that you put here is the same as the original. So if you're having originally a minus, then the same would be a minus. Okay. The next sign is opposite. So if you wrote a minus before, you're going to write a plus. Okay. And then the last one is always positive. Always positive. So you can see it works down here even with the plus one. So same, opposite, always positive. Okay. All right, last, before we go practice some of these, I want to point out that sometimes students will spend time trying to figure out if they can factor this a squared plus ab plus b squared or this guy. Yeah, no, if it could factor, it'd be factored in the formula. So you're done. Like once you use this formula, walk away, okay? Walk away. All right, So here we go. All right, so how we would do this, of course, okay, so I've mixed them all up, is the first thing I want to do is see if, hey, how many terms do I have? I have 2. I'm noticing a cube, and I'm noticing a plus sign. And there's nothing in common in both, so this is definitely not a GCF, nothing in common in both. So at this point, if I have a hope of factoring it, it's going to be that a cubed plus b cubed, a, b, a squared, a, b, b squared. So same, opposite, always positive. Boom. Okay, now 64 is 8 squared, but that's not going to do us any good because I need a cube. So this is a good point to, if you aren't familiar with your cubes, 2 cubed, 3 cubed, 4 cubed, memorize the first couple. 4 cubed, 64. Okay. All right, so here's how it's going to work. So everywhere I see an A, I'm going to put an X. Everywhere I see a B, I'm going to put a 4. And that's it. Now, technically, it'd be X times 4, but we know that we always put the number first and the letter second. And don't just write plus a 4 squared. That's bad math. Just write 16. And boom, you're done. Done. All right, so let's go to the next one. I have 2 terms. Squared. So if this has a hope of factoring, then this has to be a perfect square. Okay. So what I've got going on here is this is the a squared minus b squared. A minus b, a plus b, boom. A is x, b is 3, and we are gonna just swap it in and call it good. Woohoo! Okay. Awesome. Now, some of you may be having flashbacks to, I remember after I factor, I set each factor equal to 0 and I solve. Okay, that's when you are solving a problem, like you originally were giving an equation to solve. This is just asking us to factor and walk away. So that's the other tough part, is knowing when to stop. So here we're just factoring, putting it in this nice parenthesis form, and then calling it good. All right. These next 2, I'm going to just go ahead again, look to see if we could take a GCF out of this one. Now, the reason why I knew to go straight to a GCF, okay, is because I noticed this exponent of 5, and I was like, I don't have any formula for a 5. So what do I do? So my next kind of thought was, well, what's in common in both terms? So both terms have a W, and in fact, both of them have 3 W's that I could take out. Okay. And then both have a 6 I can take out. Okay. So if I take a 6 and 3 W's out of this first term, I'd have 2 W's left. And then if I take a 6 and 3 W's out of this term, then what is that? That'd be a 4. Now, I should say one of the things that appealed to me when I was a student and learning how to factor, you could check it. So I'm not saying you have to check it, but there is a certain amount of like inner peace, if you will, that, wow, I can distribute this back out and I should get back to the original. So if I multiply 6w cubed times w squared, yep, I would get a 6w to the 5th. And then if I multiply to 6w cubed times a 4, then yeah, I'm going to get back to what I got. And that's true up here as well. Okay. All right. By the way, are we done with this problem right here? Yeah, because this is a plus sign. W squared plus 4, we don't have a sum of squares formula. So yeah, that guy is done. My line went a little crazy there. Okay. Let's try this one for the trip to the Bahamas. If I had a trip to the Bahamas, you think I would use it on you guys? Okay. Sorry, that was cruel. I'm gonna take a 5 out, I think. Does that sound good? I don't know. Hold on. What am I thinking? Let's stop for a second. This is a y cubed and a minus. So my first thought is this lovely formula. It is definitely not a perfect cube. So right off the bat, I'm like, it's not going to work as it is now. Now, some students will say, oh, it's not going to work. I'm going to walk away. I'm done. But technically, if I look at 40, I can take a 5 out. Okay. And if I keep looking, I've got that y cubed minus, and then that 8, remember I said a few minutes ago that if you're not familiar with your cubes, you should probably memorize the first couple. 2 cubed is 8. So yeah, this is going to work. So this is going to factor with the formula. Ready? Same, opposite, always positive. Okay. So here, A is going to be a Y and B is going to be a 2. So let's do it. So by the way, what do we do with that 5? It's just going to loiter out front. It's just going to hang out. Okay, so 5, and then we have Y minus 2, Y squared plus, Y times 2, and then plus 2 squared. There we go, people. Woohoo! All right. Woohoo! As my pen comes towards me. All right. So these happen a lot. They like to sneak in, they being the textbook authors. Your instructors love to sneak in a cube or a perfect square. Those happen a lot. Okay, so don't be caught off guard. Make sure you remember those formulas. Okay, now, what if there are 3 terms? Good question. Typically, if there are 3 terms, the first thing I'm going to do is see if you can take out a greatest common factor, right? At something in common and everything. Or start doing what I was taught guess and check, trial and error, where you like try to basically reverse FOIL. Okay. So like back in my day, sounds so old, but here we go. Back in my day, what we would do is we would go, okay, I need an X and an X. And what 2 numbers multiply to 12 and add up to 7? So you'd basically sit here and guess and then FOIL it out and check it. And this one's not going to work, obviously. This one's going to give us a 13x in the middle. Well, of course, new methods come along all the time. So some of you guys may have been taught using the grid method. So the grid method basically says, okay, if I'm going to need an x squared here, I'm going to need an x and an x. I need a 12 here. So think about all the ways to get 12. And then figure out which ones add up to 7. Okay, so here, 3 and 4 add up to 7. So we're going to put a +3, a +4, and then let me go ahead and I'll make up one right now, just so you guys can see the grid method. I'm going to have one in just a second. But let's say I changed it. Let's do this guy. There we go. Okay, so how the grid works is I know that I need an x squared and I know that I need a 12. Okay? So to get an x squared, I just need an x and an x. So that's what's going on the outside. Now 12, we've got our list. 1 times 12. So if I put a 1 here and a 12 here, then we check it and see that 1 plus 12 we already saw was a failure. That was 13. So I think 2 and 6 are going to be my best bet. So this is how it works. So you put 2 on one side and 6 on the other. All right, now what we do to check it is we go, okay, 2 times x is 2x, 6 times x is 6x, and yes, you'll see that 2 and 6 and x and 12. Yes, it works. Okay, now where's our answer? Well, our answer is we used a +2 and a +6. So this is one parenthesis, and this is the other parenthesis. You don't have to use this specific method, but I'm just trying to show you there are options, but you do need to be able to factor a trinomial. That's the fancy name for 3 terms is a trinomial. All right. So we'll try one. Let's do it. Okay, so up here, okay, and yeah, if you want to go old school and just guess it here, that's totally fine. I have no problem with that at all, because that's the way I do it. So here, the trick with this one is we need a -6. So that means we need one of each sign. Okay, so we would need like a -1 and a +6, or a +1 and a -6, or a -2 and a +3, or a +2 and a -3. And so if we look at this combination and we want them to add up to -5, it's going to be this guy. Because remember, when I multiply to get -6, I need one of each. Okay, so here it would be x plus 1 and 6. For those that want to see the grid in action again, I'm not saying it myself because it's still kind of new to me. Okay, there's x squared. So I need an x and an x. Okay, I'm going to write a -6. So I got to figure out this list, right? -6. So a -1. So I'm basically, when I use this grid, I'm creating all this list in my head or on my paper. And once I find this +1 and a -6, that I would write a +1, a -6, and then we'll check it. So a -6x, a +1x, and yeah, we would end up getting on this diagonal, this is going to add up to a -5x, which is what we want. Okay. All right. Whew, we're almost done, guys. We're doing great. All right, so over here, so the first thing that I noticed when I look at this one with 3 terms is I'm like, geez, all these numbers are bigger than we've been playing with, and y cubed, what the? So I'm probably gonna try a GCF. Anytime I see big exponents or big numbers, I'm gonna think, can I take anything out of everybody? And right now it looks like I can take a 4y out of everybody. So if I take a 4y out, this would be a y squared. 16 divided by 4 is also a 4, and there'd be 1y left. And then lastly, I'd have a minus, and 12 divided by 4 is 3. Oh, but I'm not going to have a y. That y is gone. Okay. So I have a 4y, y squared plus 4y minus 3. Okay. Now, here's the deal. Can we factor what's left anymore, right? Okay, well, this is where it's helpful, to have this idea of how do I get a -3? To get a -3, I would need a -1 and a +3, or a +1 and a -3. Well, guess what? Neither of these are going to add up to 4y, so this is done. You can't factor this anymore. Got it? So there's only 2 ways to get a -3, and neither of those will add up to a positive 4y. Okay, let's do this one. That's a weird cube, but we're gonna go with it. And it looks like, yeah, this exponent of 5 is definitely throwing me off. So the first thing I'm gonna do is take out a GCF, and it looks like everybody's got a q to the third. And I'd have a 3q squared minus q minus 2. Okay. Now, these are a little bit harder to keep checking the factor because it's not just a q squared in front or an x squared in front, it's got a 3. So I'm going to go ahead and do my little grid. Okay, let's see how it's going to work. So to get a 3q squared, I would need a q and a 3q, either order, but I need a q and a 3q. Okay. To get a -2, I'm going to need a -1 and a +2, or a +1 and a -2. So I'm just going to guess. I don't know if this is going to be good or not, but we're going to see. Okay, so here a q times a -2 is a -2q. A 1 times a 3q is a positive 3q. And when I look at this diagonal, I end up with a positive 1q. What did I want? A negative. Okay, so if you're off by a sign, when you go to guess, we're just going to flip the sign. So here, this would become a negative, and this would become a positive, and then we're going to check how it works. So this will actually factor into, you ready for it? q minus 1 and 3q plus 2. Woohoo! All right. Did it. I did it. You watched. Hopefully you played along. Okay, what if there are four terms? Oh my God, please no. I'll be honest with you, factoring four terms is pretty rare in calculus. It doesn't happen that often. I'm not saying it won't happen, but it's maybe one problem in, 200 will have you factoring four terms. So typically what happens is you try to take a GCF out of everything, and then if that doesn't work, there's a method called grouping. So here I've illustrated it for you. I will just say right now, I would not spend too much time trying to learn grouping because it doesn't happen that often in calculus. I know it's cruel, but it's true. So if it factors, so that's the big thing is if it factors, not all four terms factor, what you basically do is break it off into pairs. So you can see here, I've split it exactly in half into two pairs. And what you do is you basically take a GCF out of each pair. So I took a 2x squared out of the first pair and a 7 out of the second pair. Okay. Now, what you want to have happen is the stuff in parentheses is supposed to match. Okay. If it doesn't match, you're done. It's not going to factor. Okay. So if it factors by grouping, what's left in parentheses will match. Okay. So what happens if this miracle occurs is you factor out the piece that matches. So this x minus 3 is what matches. So it's out here. And then you write what's left. So what's left is a 2x squared and a 7. And so there you go. Factoring by grouping. Like I said, don't waste too much of your time trying to do that. But so I don't get my math teacher card revoked, I had to at least show you it. Okay. So some final thoughts. We're at the end. The biggest thing I would say is just awareness. Once you know you're going to factor, look at the number of terms you have, and that will tell you what method you have for yourself, right? So if it's 2 terms, you have all those formulas. If it's 3 terms, you're going to do the guess and check grid thing. The other thing you need to realize is that this is just on the basic fundamental concepts of factoring. Calculus, it can get gross, okay? And what do I mean by gross? We're going to see some examples that involve roots, that involve e to the x, ln, trig functions like sine and cosine. So the better you are at the basic stuff, then as I start to pile the other functions on you, you should be more savvy, okay? So you want to strengthen these skills. And yes, we are going to be using them. All right, so keep practicing. Please, please, please. The better you are at factoring, the calculus will come a lot faster. So until next time, take care, work hard, and I'll see you later. Bye-bye.